Okay, in this presentation what we have to do is find the Laplace transform of this expression here. F of s equals s minus 1 over s squared minus 2s plus 5. Okay, so usually what you should try and do in this situation is try and factorize the denominator and see if something comes out easily. Okay, but in this case it doesn't really work. Okay, I'll just let that set for a second. In this case it doesn't really work. Now you can factorize it. The minus a plus or minus square root formula, that one will work, but it just won't give you an answer that you will be able to use easily. Okay, so what we're going to try and do is actually take an alternative approach. Okay, so the first thing I'm actually going to mention here is that I'm just going to roll this back down again, that the numerator is s minus 1. Okay, so what we might do is see if we can get this in terms of s minus 1. Okay, so this is a sort of second approach to take. Okay, if that doesn't work. Okay, now, so can the denominator be expressed in terms of s minus 1? Well, s minus 1 squared, well, we got a square here. Okay, so that might help. Okay, so in terms of leading us in the direction we need to go, so s minus 1 squared is s squared minus 2s plus 1. Well, that means that s minus 1 squared plus 4 is s squared minus 2s plus 5. Okay, that is the denominator. So we can re-express the denominator as follows. Okay, so what I'm going to do actually is, just let's scroll up for a second, is that the f of s can be written as s minus 1 over s minus 1 squared plus 4. Okay, now I'm going to just re-express that. I'm going to leave it as f of s, but I'm also going to just re-express this as another function, g of s minus 1. Okay, the reason is I'm using g is just not to get it confused with f. Okay, that's the reason. That's the only reason. Okay, so I'll just go back here a second. If this is g of s minus 1, what is g of s? Okay. Well, g of s would therefore be s over s squared plus 2 squared. 2 squared being 4. So if you just sort of compare that just to what I wrote a second ago, s minus 1 is now s. S minus 1 squared is now s squared. And 4 is 2 squared. Okay. So if you actually sort of look at this and realize pretty quickly that is the Laplace transform of cos of 2t. Okay. Now there's a shifting theorem formula, okay, that is in the formula sheet as well, and it is f of s minus a is e to the t. Here we have minus a being minus 1, and the inverse Laplace transform of that is e to the t cos 2t. Okay, so sorry, I'll actually give you the formula. This is just I meant to write that down, but I actually just forgot. Okay, this is just actually a page from another presentation I was using. So it's essentially this expression here. Okay, so we have g of s minus 1. Here a is equal to 1. Okay, and what this corresponds to what I done previously there in terms of g. So the inverse Laplace transform that is e to the at times f of t, or as far as we're concerned, e to the at g of t. Okay, so a here is 1, so we have e to the t, and g of t is cos 2t. Okay, so that gives us the inverse Laplace transform of that expression there, and it turns out to be way easier than that fairly easy approach using the tables. Okay, so that's using the first shifting theorem. Okay, we'll leave it there.